Hey everybody, probably the last video I'm going to make while I'm here. I just want to show you the solar stuff, the inverter, the batteries, and let me tell you, it was not easy getting settings setted correctly and getting the batteries to communicate to the inverter and everything running the way it should be so it could push power to the house. And all they have to do now is plug in power everywhere, get the solar panels up, plug them in, and everything should run perfectly. And if it doesn't, whenever they get internet, I'll be able to manage it from Missouri. I'll be able to manage it from wherever I'm at, and we'll be able to diagnose and fix any problems that come along. So this is what we're working with. Right here, we've got two 7.4 kilowatt Discover batteries. They weigh a lot, and 130 amp hours at 48 volts, and there's two of them, so just double all that stuff up in your head. Anyway, they're networked together so that they can communicate with each other to make sure that whenever charging does occur, that one doesn't get more power than the other, and when discharging occurs, they're both equally taking on the force of whatever is being pulled from them or given to them. All right, so that communication has been quite an issue, and I'll go through that in a second. We got bus bars safely spaced apart, running equal length wire to each battery for resistance purposes, and these big nice cables running over to this inverter, which is made for industrial type situations and big draw amperage and everything. So basically, what we have here is enough power when the solar panels are hooked up to power 3 buildings with almost everything you would need. And not like big air conditioners, not space heaters, not all the luxury crap that, you guys take for granted when you have line power. And, but it will run refrigerators, washers, dryers, necessities, things like that fairly easy with no problem. The system's made to be grid tied, which we are not doing because we are off the grid, clearly. But it's a big boy, and it took me about a day and a half to go through all of the manuals, online tutorial, YouTube, this and that, trying to figure out what settings are supposed to be set for this and for that, and my brain hurts. I could scream at this thing now, but I'm so glad it's working. Anywho, this deal right here is the communication box, so that you can tie both of these batteries to it and then communicate their power levels to the inverter, right? Okay, I'm going to open this guy up. Of course, it looks like a breaker box, and it is a breaker box. It's exactly what you would expect, just in a little bit different form. We have our battery running in, right? And right here is where they'll hook up their solar panels, make everything charge without having grid power or generator power. If at some point right here they get a generator that will be compatible with this system, they can then put it in here, and we'll have to do some stuff here, wiring for these, I don't know what they're called anymore. My brain hurts. Anyway, so if for some reason the voltage gets below a certain level, it will then kick the generator on so that they'll be able to charge the batteries with the generator during some sort of unforeseen circumstances where we have weeks with just rain and no sun, or the batteries just get drawn on too much because of things that you probably shouldn't have plugged in, but you do anyway because you have the power, which at some point I'm sure that will come to fruition, and they'll we'll have to figure out, what we're going to do past that. But we can always add more batteries to the system, and we can. I have all the room on this bus bar for what, two more batteries at least, and we can buy bigger bus bars. Um, yeah. So I don't know why I switched back to me. These right here, you can have up to well, it looks like 3 panel arrays, which is a whole bunch of panels. We're putting 8 panels on top of the roof now, and that'll go all into just PV1. And if they wanted to, they could cut them down to 4 and 4 and put them in here. But I'm not sure how that's going to go about. Anywho, so this line right here clearly is the Cat 5 cable that connects this network, this battery network, together so that it can communicate with this guy right here. See, here's our voltage. Well, 53 volts, got 84%. We have no draw right now because I have everything off and nothing's really wired in. So that's pretty cool. And I'm glad that it's happened. We have the house load tied into a breaker box into the main house here, which at some point here soon, I'm sure they'll be wiring all their plugins, all their lights, all of the whatever. We have cabling running to each house at the moment, the little shack, and then what's built of our house, my house, and Dana's house right now. We have cable ran, but none of it's hooked up because we just been run. Today, Gary, Travis, and Angelo went to some town far away, a couple hours away, to buy the catchment, which is 10,000 gallon catchment that will essentially, provide water to all of these buildings that need it. There'll be a washer dryer house with probably a community shower in it, and then there'll be a shower in Gary and Karen's house, and there'll probably be a shower and and toilets and all of those things that you need, that some people require privacy for, and others could do with a shack out in the jungle with a little water heater coming off a catchment. Either way, the sand will be here for the bottom of the catchment in an hour or two, which is nice because then they can throw the sand over and set their catchment up and be ready for when the gutter guy comes in a couple days or so, next week. I'm not real sure. I've lost track of everything. I go home in a couple days, trying to get as much done that I can while I'm still here to make sure that, at least this power stuff's running. I need that. I'm glad that I got that. It took me forever, and I did not know what I was doing until I flipped some switches and read some stuff and made it all. Let's take a look at what's going on here. Alright, as you can see, this is the main panel. It'll tell you what you're getting from your panels, how much you've charged today, how much you've used today, and then how much has gone to your load or your temporary grid, I would call it. Anyway, and up here, this thing will tell you what voltage, wattage you're getting from your panels as well. This is your battery voltage and percentage, and what watts are being pulled or pushed. This is the load. It tells you the information you need to know about, there's 240 volts, so that's quite a bit. That's just the main menu. Here's our chart for our solar. Solar's not there. Batteries are there. They're at 84%. The voltage is at 53. 66 amps. There's 2 different batteries right now, so it's showing us nothing. It's just showing us them as together because I have them ran as one. So, it's got all that information. Here's the grid. You could also connect this to the grid so that you could use it as a backup or sell power to the grid. UPS, not sure what that is. We don't use it. And this is all just more information that I'm not really sure what it is yet, because we don't have everything hooked up in a way that that information is accessible. So we have our alarms here, and it'll tell you, of course, all of those things. Inconsistencies, your faults, bus short circuits, relay faults. Oh yeah, relays. That's what those are. Those are relays for that will have to be hooked up if they decide to hook a generator up. Those things will have to be hooked up to this power box over here so that it can say, hey, the batteries are too low. Click. And it'll switch the from battery power to generator power to create a charging load, which would be awesome. Alarm status. This is where I've been at most of my days. That battery comm failure at the very top left there has been really getting with me until I figured that out, and I'll show you that in a second. But you know, it'll tell you if anything's wrong, and of course you've got your lights over here that tell you stuff. Fault record. Good, it's gone. Alarm record. See? Battery volt low. When was that? 12. That's because I shut one of the batteries off. The batteries were open, which means they weren't in a closed loop, which is not real serious of an infraction at this point because it's working. Anyway, settings. Boop. If I can get there. Settings. So, oh, it's saying to feed into grid. We don't want to do that, so let's go ahead and reset that. Charge. We're using battery voltage to set charge current limits. And float voltage and absorption voltage, look it up if you don't know what it means. I'm not setting it because we don't have any charge coming in. Generator, that's where we tell the generator, hey, if it gets this low, then you need to start up. And no AC coupling because we're not tied to a grid. Discharge. So battery discharge control. That things would be set there if we were connected to the grid once again, and it would use a percentage that comes from this communicator over here to tell us, hey, at this percentage, cut it off. And that's also part of the settings for generator, because we'll never be on grid here. Forced discharge is also a power grid situation, so it's not really used. It would be telling it, hey, between this time and this time use only batteries, but every other time use grid power or generator power. Alright, grid peak shaving. Grid peak shaving is another thing for if we were on the grid. What it would do is it would take, through a certain time, it would take a percentage of grid power and a percentage of battery solar power and use them together to try to minimize your bill, which is a nice feature, but once again, not something we need to use. We don't need that. All right, PV input. There is no, PV is the, what is the acronym or whatever they use to symbolize the solar panels, right? There'd be a meter on that, a phase meter, and all that stuff is also still for grid usage. Even though when they do put panels on, they will have to tell it that there is or isn't panels and where they want them to go, and the ratio of, you know, that the ratio doesn't much matter because we don't have grid power, so it's makes things a whole lot easier. And seamless switch, and you know, all these little things right here do not make a difference. Smart load, run without grid, that is also, you know, grid power stuff. PV arc, that's for if there's some sort of fault with the solar panels. See, grid type, don't use. Here we are, battery type. Yes, I know we have lithium batteries, but for our system and the network to, from the batteries to communicate with each other, we have to tell the inverter that it's lead acid so it can get the percentage of battery left by understanding what the voltage is. So I've set the lithium brand to 2. That was a hard one to find too. And the capacity amp hour, of course, we have 130 amp hours at 48 volts. So it must be set correctly so that it does not destroy the batteries, and it is, so no worries. Parallel system, that is more battery stuff for phasing in your grid power. And since we have parallel batteries, I should tell it to share batteries, shouldn't I? Uh-oh, password. Anyway, go back down. Let's tell it to share the battery. Oh. And we cannot because they are set as lead acid, because otherwise they do not communicate correctly. So that's about all that. Little debug section, build firmware, whatnot, all that good junk. It's not that hard of a system to make work if you have some experience, which I did not, so it was very difficult for me, and I was stressing because I want to get this all working before I have to leave, which it is now. Everything's fine, and all I have to do is put in their panels and make sure that those settings are correct, and I believe that there will be an engineer on site at some point to make sure that those settings or the wiring and whatnot is correct, so that way it's all ready to go. So I'm gonna shut that deal. Click, click. And that's about all for solar. Let me go show you where the catchment's going. I know I showed you guys that at some other point, but we're gonna go over there anyway. And then I'm gonna show you what, you know, the power cables that we have ran from breaker boxes to going to the cabin and our house, which you guys are going to laugh because, you know, we don't have power poles, but we have ohia trees. And these ohia trees take forever to grow an inch. There's trees out here that are, you know, as small as my wrists or my legs or whatever, and they've been there for 100 years, and they don't grow that fast at all. So I'm going to pause it, and I'll be back. As you can see, our powerhouse done well. We're going to put a screen up there to help vent. That door will be screwed shut so as to not let anybody who thinks that they need to be in there for no reason get in there. There's our power running up there, and our power pole ohia trees running across into the house over to a breaker. So they put some stairs in right here, which is nice because now I don't have to jump up and down there. Nobody will. It's a little bit safer. It's going to prevent slips, trips, and falls, hopefully. This is the aftermath of all the rock we had the other day. It's now flattened out, nice and well. You know, a little path here so you can get down, whatever, from that turnaround we made a long time ago. It's going to be a big old steel, basically pool. It's basically a big steel swimming pool with a liner and a cover to keep stuff out, and they will plumb the house, the guttering off of the house into that, and then off from that it will go to a pump house where there will be a pressure tank and a pump and filtration and all that stuff you need to get rainwater to be usable water. It's a pretty nifty situation, actually. We have sand coming today. I think I mentioned that. It's going to go right there. He should be here in an hour or so. You know, everything's come right along. It looks like a mess right now, but you know, it's a job site, so it is what it is. Right, cabling running all the way across, if you can see. I'm not going to show you that breaker box because somebody will be like, oh no, you can't do that, but it's just for testing purposes. I got to take this cord down, but that cord is running power to this nice little spot here. And then I have cable over there on the ground that's going to run from a breaker box in here over to my house, of course. So very exciting stuff. I didn't know if I'd be able to get that power running actually but a little bit of ingenuity and a lot of reading and a lot of listening to YouTube videos and calling tech support a few times to see what they would say. A few tech support tickets that got answered generically, so that was kind of frustrating, but that's why I called and talked to a person, because it's much easier to explain to a person what's going on than trying to type out, oh, well, I've got this, this, and this, what should I do? And they're like, oh, read the manual. I read the manual like 6 times. It's Greek. Anyway, that's about it for now. We'll give you a little bit later if there's anything. I don't know what's going to come or what time they'll be here with the catchment. They had to go at least 2 hours away, and it'd take an hour or two to load or so. I don't know. Depends on how it goes. And then they'll be here and basically just screw it all together and throw a liner in it and hope for the best, from what I understand. It all looked very good, though. It all looked like it was quality material. It's secondhand, but it's exactly what we need, and it's much cheaper, and money makes a difference around here. So if you can find something for cheap, you can get a hold of it, and you deal with what you've got. Anyway, I'll catch y'all later. And because I don't remember what I've shown anybody or done here lately, we also have acquired some, what are they, 380 watt panels, 380 watt panels to put on top of my house with the old lead acid battery system that we've been using since we got here to keep all of our stuff going, which will serve purpose just fine for backup necessities and things like that. I've got one panel hooked in right now, and it's been charging pretty well on this cheapy inverter. We've got these lead acid batteries. They're doing pretty well. We'll run the old inverter and stuff in our house for just backup in case something unforeseen happens, or we just want to click off the power. I don't know. It's just another safety type thing in case of. But so that's those right there. They look similar to these, but these only have one face on them. The backs are metalled, but we got them for very cheap comparatively to other panels on the market. These deals right here, they not only do they have cells on the face, they have cells on the back, which means any type of reflection off of the roof will be caught as well. So there's essentially a higher consumption rate. Their efficiency is much better than, say, those panels over there with just regular backs on them. These bad boys are big. I'm looking for it. I can't remember. They are 550 watts each. That is a lot of wattage. And there's 8 of them. And that's what will power that big system I showed you earlier. And I think it'll do it efficiently. We're having professionals come put those on the roof because there's big spikes that have to go through the metal, concerned about leakage, and if, say, we did it, it might leak and we would be kind of screwed. We'd be stuck to our own devices to try to figure out how to fix that, which would require pulling panels, which, you know, anytime you handle these things, you have to be careful because they're glass, and, you know, it just increases the chance of breakage, which terrifies me because there's lots of money sitting there. But we'll have some professionals come out and do it for us, and if they mess up or if anything happens, it's on them, not us. And we all feel much safer having that be the case instead. So with all that said, I think power is pretty much set here. All they have to do is plug in panels and flip a switch. As far as water, it's about to be that easy too. Travis is going to plumb everything, He knows what he's doing with that. They've let me deal with this power stuff because, I've got a better handle on that than some others. And, we all got to get in where we fit in. Everybody's done a really good job making everything work out here. Although I am leaving, I feel very confident that they will continue to progress in the same manner and speed as we have, except for, they'll have to get actual jobs, which is a necessity because money doesn't just fall out of the sky. And so that will leave them half the time to work. The kids will be in school as they are today. I will be going to pick them up here shortly. And, so when they get home, I'm sure they'll have chores and there'll be plenty to do around here for the next couple years. Whenever I finally get back over here, bring my family, and we will have plenty to do also. We have a whole house to put together, and more land to clear, and plenty of things to keep us busy outside of a normal day job. But it's all the process, it's all part of life, and it's all got to be done. So, till next time, guys, I'll be home in a couple days. We'll see you then. Bye.